This video is going to cover the topic of proportions. Be sure the date and topic are at the top of your page. The essential question of this video is, what is a mathematical proportion? Some of us have been using proportions for a while, but we haven't used the term proportion. So let's see what that actually means. A proportion is an equation, and in the equation it states that two ratios are equal, that they are connected and related. We can also see that these are sort of like setting up equivalent ratios in the form of equivalent fractions. The only thing that looks different is that we use a variable x to hold the missing value. In general, proportions look like a fraction that is equivalent to another fraction, but one of the parts of the fraction involves a variable such as x. Let's take a look at this rate question, something we've seen before, and just see what this would look like with proportions. We know lots of ways to solve this problem. I can run 2 miles in 17 minutes. How far can I run in 34 minutes? If we want to do this with proportions, we simply write the ratio or rate as a fraction. So I can do 2 miles in 17 minutes, and I want to know how far I can run in 34 minutes. If we want to call this a proportion, all we need to do is use a variable like x to say that this is an equation with a missing number that I need to find. And of course we know what to do from there. I know that 17 was doubled to make 34, so I'm going to double the number of miles I can go as well, and that will tell me what my missing value is. It tells me that x is equal to 4 miles, so I can go about 4 miles in 34 minutes if I maintain my same pace. So this might not be anything particularly new, but it just has a new name. So you might hear me call this a proportion, or setting up a proportion when we work on it together. Here's another proportion. Dogs outnumber cats in a particular area by a ratio of 9 to 8. There are 180 dogs in the area. How many cats are there? So let's take a look at what we know. We know that dogs are represented here by our 9, and cats are represented by our 8, and we know that there are 180 dogs. Our job is to figure out how many cats there are. We're going to set this up as a proportion. What's different here from what we've done recently is that we're not finding a unit rate. We're not trying to find out when one of the numbers is 1. We're just trying to scale this and make sure that our ratio is equivalent as we scale up or down. So here we have our proportion set up, and I want to point something out that's very important. And that is that your units must match. So you can see here that on this top part of my ratio, I have dogs, and I have dogs on the top part of the equivalent ratio or proportion as well. The same units are on the top, and of course the same cats and cats are both on the bottom. That's always going to be very important. I can see pretty quickly on this one that I'm scaling my proportion up, and it happens to be that I am multiplying by 20. I have 20 times as many dogs, so since that's the numerator in my proportion, right, set up as fractions, then I'm going to do the same thing here to the bottom, the denominator. I would need to multiply 8 by 20, and I find out that my missing number is 160. So in this case, there are 160 cats. And that's it. That's me solving that problem set up as a proportion. For your turn, I want us to think about a ratio of red Skittles to orange Skittles, that is 5 to 3. And using these proportions, I want to see you set up equivalent ratios in proportion form to show how many red Skittles there are if there are 27 orange Skittles. The essential question was, what is a mathematical proportion? And we've seen with these examples that a proportion is when we set up an equation that shows that two ratios are equivalent, and we can use those proportions to find a missing part of our ratio. We'll of course be practicing this more in class, and we'll talk about any questions you might have.